Welcome everyone. Today we will learn how to perform a MongoDB CRUD operation in a nested core with API. So as a prerequisite, we'll install Docker Desktop to run a MongoDB instance container. I'll provide all the links in the description below. So in this guide, it explains how to install a MongoDB Community Edition with Docker. So the first step is to pull the MongoDB Docker image by running this command. I'll skip this command because I already installed the image. The second step is to run the image as container. With this command, copy and open a new terminal window, paste it, define a different name, in this case MongoDB CRUD, and specify which port to use. The container port will be the default MongoDB port, that is 27, 0, and 17, and the host matching port, which can be the same. Execute it, and the third step is to validate that the container is running by running this command. And as you can see, our MongoDB instance is up in the default port we defined. So in order to visualize and create a new collection in this MongoDB instance, we'll install MongoDB Compass, that is a graphical user interface for MongoDB. Feel free to download and install this application. I already installed it, so I'll open MongoDB Compass and create a new connection. Click new connection, and in the advanced connection options, select the default connection string scheme, and here define the host, which is localhost, and the default port that we selected. Define new connection name if you want, Mongo CRUD. Click save and click connect. As you can see on the menu, we have three default databases that MongoDB has created for us. So click in this button to create a new database, count, and the collection name, use create the database, and as you can see, we have the database and the collection. This collection has no data, so far so good. So go to Visual Studio and create a new ASTA.NET Core with API. Click Nets, define the name of the project, click Nets, and create the new project. To connect with the MongoDB instance, we need to add a new NuGet package called MongoDB driver. So right click on the project and click Manage NuGet Packages. In the Browse tab, search for MongoDB. Click the third option, that is the official .NET driver for MongoDB. Click Install. So in this project, create a new class called MongoDB service to define all the CRUD operations we want to perform. So add a new class called MongoDB service, add a new constructor, and create a new database variable. In this case, we will create a new MongoDB client using the install package. And here we need to pass the connection strings from the MongoDB instance. So go to the app settings.json and add the connection strings section and a property called MongoDB. Go to the MongoDB Compass, and here in this pop-up menu, you can copy connection string from this instance, paste it, and MongoDB service inject the iConfiguration interface to access the app settings information. So call configuration that get connection string and pass the name of the property, in this case MongoDB. We have our Mongo client that use this method to get the database, which is account, and now define a new property called collection, this database that get collection. In this case, a new class called user, and the name of the collection, that is user. This user is a class itself that will represent the collection on MongoDB instance. So let me rename this weather forecast default class to user and define all the properties. The first one is ID property and assign a default value. This default value is the case when we're creating a new user. At the following properties: name, age, and a date-time property called birth date. Here in the MongoDB service, we have our user collection binded to the user class. So we'll generate a read-only field collection that will be used in all the CRUD methods. Now just define the first CRUD operation, that is create. So the methods will be asynchronous, create. The argument is the user, and using body expression called collection that insert one async function passing the user. The second CRUD operation is read will return the user based on the ID passed collection that find a sync. And here we can use expression, lambda expression, to filter the collection based on the ID, and this returns a list. So we need to select the first item with the first or default function. The third CRUD operation is to update user. So we pass user as a parameter. In this case, we call the replace one async method. It will take the filter definition. That's the same filter definition we define in the read method user.id, and the second parameter is the user itself. And finally, we have our delete method based on the ID of the user, calling the delete one async method based on the ID. Now we have the MongoDB service defined using the MongoDB driver to access the collection. Now go to the controllers. This is the default controller, so let's rename it as user controller. Get rid of all code. Add a new constructor to create a new MongoDB service instance. So MongoDB service, new MongoDB service, and it receives a configuration interface. So inject the configuration dependency and pass it to the MongoDB service constructor. Declare this property and add the respective HTTP requests for each CRUD operation. First one is for create, so use the HTTP host. It will return task create that receives user and call MongoDB service.create. Perfect. Second HTTP method is get, that will return an user based on the ID, calling the MongoDB service.read method. The third one is the HTTP patch to update the user. Task date, passing the user and calling the update method. And in the end, we have the HTTP delete. We'll delete an user. MongoDB service that delete. Here comes a warning. Please don't do this in production. This demo is just for testing purposes. It's a proof of concept. In my next videos, I will explain how to integrate this code using best practices. So saying that, run the application and let's see what happens. Okay, we have this Swagger UI. Test the post method. As I mentioned, in the post method to create a user, we don't have to define the ID. The name, let's type Joe, the age, and the birth date. I will let it as the current date. Execute. So far, so good. So go to the MongoDB Compass and click this Find button to see all the documents in the collection. And as you can see, we have the newly created document with the name, the age, the birth date, and the ID. There is a random width generated in our code. We can verify that the user was created by copying this ID. Execute. And as you can see in the response body, we have all the properties related to this ID. Use this patch method to update the user, passing the ID, the name, Joe2, the age maybe 40, and execute. Perfect. So go to MongoDB Compass and click Find. Have the name and the age updated. You can execute again the get request to see the updated properties. And finally, test the delete method by passing the ID. Execute it and go to the MongoDB Compass, and there's no any document in the collection.